Before the first golden ray of sunlight stretches across the American heartland, a quiet revolution is already underway in the fields. U.S. farmers, once reliant on muscle, sweat, and instinct, now command fleets of high-tech tractors that resemble something from a sci-fi film more than a traditional farm. In this digital age, agriculture is being rewritten, acre by acre, by innovation. These aren't just machines with wheels and engines, they are intelligent, GPS-guided powerhouses loaded with software, sensors, and connectivity. And the result? Bigger yields, more efficient farming, and crops grown with surgical precision. At the core of this transformation is the modern tractor. But to call it just a tractor is almost misleading. Today's machines are smart devices on wheels, many of which are semi-autonomous or fully autonomous, able to navigate massive fields without human intervention. These high-tech marvels are equipped with GPS mapping systems that can remember the exact contours of every inch of a field. They can identify the best planting paths, avoid obstacles, and adjust their strategies based on real-time data. Farmers growing corn in Iowa, soybeans in Illinois, or wheat in Kansas can now optimize planting and harvesting down to the square foot. One of the most important tools these tractors use is precision agriculture software. This software collects and analyzes data about soil quality, moisture levels, crop health, and past yield performance. Sensors installed on the tractors scan the soil and crops continuously. If a section of the field is found to be dry or nutrient poor, the tractor can automatically adjust seed density, fertilizer distribution, and irrigation. For instance, in a field of corn, a high-tech tractor may plant more seeds in areas with rich soil and fewer where the ground is sandy. This level of tailored planting ensures that no seed is wasted and each has the best chance to grow into a healthy, productive plant. The role of data doesn't end there. These tractors are part of a larger ecosystem where every pass of the machine over the field adds to a growing digital map of the land. When a farmer is working a field of soybeans, the machine tracks everything: how much seed was used, how fast the tractor was going, how deep the seeds were planted, how much water was sprayed, and even how many weeds were detected and eradicated. This data is uploaded via satellite or cellular networks to cloud-based platforms, allowing farmers to access it anytime, anywhere, even from their smartphones or tablets. They can compare results over multiple seasons, test new techniques, and make smarter decisions each year. One of the most jaw-dropping features of these machines is their ability to perform variable rate applications. Instead of applying a uniform amount of fertilizer or pesticide across a field, the tractor can deliver different amounts in different locations based on real-time needs. In a massive field of wheat, for example, if certain areas are pest-ridden while others are not, the tractor knows precisely where to spray and how much, minimizing chemical usage and reducing environmental impact. This precision saves money and protects the health of the land, ensuring it can remain productive for future generations. Autonomous driving is another breakthrough. Some of these tractors can operate with minimal or no human input. They drive in perfectly straight lines, turn accurately at the ends of fields, and even coordinate with other machines. This means a farmer can set up a system where one tractor is planting soybeans while another follows behind fertilizing, and a drone overhead surveys the work in real time. The days of long, back-breaking hours on the tractor seat are fading. Farmers now act more like tech operators, monitoring systems and making strategic adjustments based on data rather than physical exhaustion. Drones, satellites, and artificial intelligence are also playing key roles in this high-tech ecosystem. A farmer growing strawberries or specialty crops can use drone imagery to identify diseases before they spread, measure plant health, or track growth stages. AI algorithms analyze the data and send alerts to the tractor systems, which can automatically adjust course, dosage, or strategy. This kind of synergy between machines allows crops like tomatoes, lettuce, and even grapes to be nurtured with pinpoint accuracy. With labor shortages plaguing agriculture, these systems are not just innovative. They're necessary. In the California Central Valley, where almonds and citrus dominate, farmers use autonomous tractors for deep ripping the soil, managing irrigation systems, and even applying compost. The terrain and microclimates vary greatly, but the tractors adapt thanks to sensors that read soil temperature, humidity, and pH levels in real time. Instead of flooding an entire grove with water, the machine waters each tree based on its individual needs. With droughts and water regulations tightening, this kind of precision could be the difference between profit and loss. Meanwhile, in Texas, where cotton rains, farmers rely on these machines to navigate large, uneven fields that once required a team of workers and days of labor. Cotton picking today is a coordinated ballet of machines, tractors with onboard balers, harvesters with real-time monitoring tools, and sensors that ensure each boll is collected at peak readiness. These smart tractors measure fiber quality on the go, tagging each section of cotton with its yield and characteristics, which helps determine market value even before it leaves the field. Even during planting season, these machines are game changers. In Nebraska, farmers growing sorghum use variable depth planting technologies integrated into their tractors to ensure that each seed is placed at the exact depth required for optimal germination. Seed meters controlled by AI monitor the spacing between seeds with millimeter precision. Such accuracy boosts the odds of each plant developing a strong root system, leading to higher resistance against drought or pests and resulting in better yields. The advantages of these high-tech machines extend into sustainability. By applying fertilizers and chemicals only where needed, the risk of runoff into waterways is reduced. This protects surrounding ecosystems and aligns with increasingly strict environmental regulations. Furthermore, reduced chemical usage means healthier soil over time. Cover crops like clover and rye, often planted between cash crop cycles, are managed by these tractors to enhance soil fertility and reduce erosion, tasks once dependent on intuition but now backed by hard data. One of the most exciting developments is the integration of machine learning. These tractors not only perform tasks but learn from them. Every pass over the field teaches the system more about how the crops behave under different conditions. With enough data, the AI can make planting or harvesting recommendations based on weather forecasts, past crop performance, or even market demand trends. A farmer growing barley for a brewery can know, with surprising accuracy, what variety to plant and when to maximize both yield and flavor profile. Connectivity is the backbone of all this technology. Internet of Things, IoT, devices embedded in tractors connect with weather stations, drones, storage silos, and even market platforms. When a frost warning appears on the forecast, the system can alert the farmer and suggest cover actions or spray schedules. If corn prices surge unexpectedly, a farmer might get a notification suggesting early harvest if conditions are favorable. This real-time responsiveness gives farmers an edge in a volatile market. But none of this would be possible without the skill and adaptability of the American farmer. While the machines are advanced, it takes vision, courage, and deep-rooted knowledge to adopt and master them. Many farmers attend workshops, tech expos, and online training to keep up with evolving software and hardware. They tinker, troubleshoot, and test tirelessly, treating every season like a high-stakes experiment. In their hands, a cornfield becomes a canvas of innovation, each row planted with intention and guided by data. In vineyards across Oregon and Washington, where grapes for high-end wines are cultivated, autonomous tractors are now used to prune vines, manage weeds, and even assist in the delicate process of harvesting. Because grape quality can vary dramatically with sunlight exposure and soil variation, GPS and LiDAR-enabled tractors help ensure uniformity by mapping the terrain and adjusting actions based on micro-conditions. This high-level control contributes to consistent flavor profiles and allows vintners to meet the demanding standards of global wine markets. And then there are the greenhouses and vertical farms sprouting in urban areas. Even here, compact autonomous tractors and robotic platforms play a role. Whether it's hydroponic lettuce in Chicago or microgreens in Brooklyn, the same principles apply: data-driven decisions, automated care, and smart machinery optimizing every step from seed to harvest. These urban farms rely on tech trickling down from large-scale field operations, proving that innovation in tractors is helping reshape agriculture everywhere, not just in rural landscapes. In the end, the story of U.S. farmers using high-tech tractors is not just about gadgets and machines, it's about resilience, ambition, and the relentless pursuit of better ways to feed a growing world. From soybeans in the Midwest to strawberries in Florida, from wheat fields in the Great Plains to vineyards on the West Coast, farmers are embracing the future. With every sensor reading, every satellite pass, and every seed precisely planted, they are redefining what it means to work the land. And in doing so, they're not just growing crops, they're growing possibilities.